Hello friends, so today we are solving this problem, maximize the number of target nodes after connecting trees. 1. So there exist two undirected trees N and M nodes. Okay, you can consider like this. This is one tree, this is another tree. Okay, so let's read the question first. So with distinct levels in the range 0 to n minus 1 and 0 to m minus 1. So you can see here, we have the different levels to them. So 0 to 4. So there are 5 nodes which are noded from 0 to 4. Similarly, here also we have 8 nodes which are numbered from 0 till 7. Okay, so you can consider these two graphs or two trees basically given to us as per the question. So what we have to do is, means there is an edge from 0 to 1, 0 to 2, 2 to 3. So all the edge information is given to us. So you can see here, these are the edges. The green icon here are the edges and red one here. So you can observe one thing in this graph. You can see there are 4 edges, 4 green lines, right? That means there are 5 nodes. So whatever is the number of edges, then number of nodes would be whatever number of edges plus 1. Similarly, you can see here there are total 7 edges and the total 8 nodes are there. So edges plus 1, right? So now let's read the complete question. Now what we have to do here is node U is the target to V. Okay, if the number of edges on the path from U to B is less than or equal to K, so basically one number K is given to us. So at the K distance, up to K distance or lesser than, how many nodes are there, that is called basically the target. For example, if you see here K equal to 2. So if we talk about this 0th node, okay, for this node K equal to 2, so all those nodes which are at a distance of 2 means the number of edges is the called distance. So whoever node at the distance of 2 or lesser are the total count would be called the target. So for example, 0 itself is a target. So 1, right? Now this guy, node 1 and node 2, they are at a distance of 1. So 2 nodes we found which are still lesser than this K, right? Now if we look at 3 and 4 node, they are also 2 distance away, right? So we found another 2, right? So in this case, if for this graph only, for this 0 node, how many found? So we have found target equal to 5 for the K equal to 2, right? So those at a distance of 2 or a lesser distance, including the node itself. So for 0th node, 5 would be the target when K equal to 2. Okay, so similar things we have to do for all the node of the graph 1. Now there is one more condition, that is why we have graph 2 also into the picture. So let's see that as well. Now so return an array of n integers answer means the for first graph we have to, whatever is the length of how many number of nodes are there, that length should be the answer array, and we have to find the maximum possible number of nodes target to node I of the first tree if you have to connect one node from the first tree to another node in the second tree. So same thing what we have to do is, so far we counted 5 here, but we are given in the question that we are free to connect any one of these nodes to any one node of the second graph. Now what would be the target? Because in the single, in this case we found the target equal to 5. Now we have to find a node which will maximize this target to connect with the second graph. Okay, so let's do that. So let me remove whatever I have counted here. So I'm just removing it. Now we will talk about the second graph. Okay, so we have to, so here in 0 we found 5 as the target, right? So let me write down for 0th node in itself I found 5 as the target for K equal to 2, right? We found 0, 1, 2, all of them are within the range of K equal to 2. So we found this 5 when it was inside it. Now in the second graph, what we have to do is, in the second graph basically we need to check that which is the graph which will maximize, which node can maximize. For example, forget about this for a moment, let's talk about this. Okay, so if we connect any node in general, let's say I connected to this node. If I connect to any node, one length will be already occurred here. So let's say if I connect this, then one length is there. So that means from any node, whoever node I am connecting, I have to find the k minus 1 length node, because 1 is already occurred here, and we are finding all those distance which are k or lesser. So in this case, if I connect, let's say 0th node to any one of them, then I have to find k minus 1th distance for the node which I am connecting, because we are interested up to k, right? So what will happen then? So from, let's say I'm connecting here, then what, k equal to 2, then from here we have to find all those nodes which are at a distance, maximum distance up to k minus 1, which is 1 in our case, right? So now this k would be 1 here, right? K equal to k minus 1 for second node. Then who all nodes are giving us maximum value? If we choose this guy, this is giving us 4 nodes, right, including itself, and these 3 nodes are at a distance of 1, and this guy also at a 0 length. So we are finding total 4. Can we find further better? Let's say, let's try this guy. So how many nodes are there? This guy is connected to this and itself. So this is giving us only 3 nodes. Now let's try about this guy. So how much this is giving? This is giving at most distance of 1. This is giving total 4 nodes, and this also giving total 4 nodes. So we have to pick one of them. Others are lesser. So we have to find a maximum node which has giving us the up to k minus 1 distance. So in this case, let's say I am going with this guy, 0th node. So if I connect, I will get a total 4 target of k minus 1. So now what will happen? If I connect this guy to this, 5 is already there for this guy, 0th node, and 4 I am getting from here if I connect it, right? So they are also in the range. You can visualize here. If I connect this, all these guys are within the range of 2, right? So what will happen? New values here. So let me remove this thing. 5 plus 4 is connected, so we are connecting to 0, right? So what will happen here is this guy would be, now it was 5 value already and 4 we are getting here. So 5 plus 4, this would be 9, right? So we are done for this guy, 0th node. Now we're looking for the other node. Let's say we are going with node 1. Okay, so when we'll go with the node 1, we will again check with a similar way. So see here, what is happening? How many up to k equal to 2 here? Okay, so how many nodes are connected with the 1 which are at a distance? So this guy at a distance of 2, this guy is at distance of 3, so we will not count it. This also at a distance of 3, we will not count it. So only 2 and 0 and itself, so only 3 would be there. Okay, so from this graph we are finding 3 for it, right? Now similarly, we have already find the maximum node of k minus 1, which was 0 or 4, right? So we are going with one of that, which is creating maximum value, right? So this guy was creating maximum value for k minus 1. So what we will do is, whatever maximum, every time we will get that connected to this guy. So it is producing every time for us the 4 nodes, correct? So 4 node of it, and 3 node is connecting by this guy, right, at a distance of 2. 3 targets it is getting from this graph itself, and 4 from the maximum every time from the second graph. So 3 plus 4, what would be the value? Value would be 7, right? So let me write it down. So this value would be 7, so we can write it down as 7. Now we are coming to basically this guy, 2. So what is the target here for 2? So see here, at 2 distance we have to find. So this guy is also 2 range, this also in 2 range, this also at a 2 range, this also at a 2 range. So all of them we are getting, right? So total 5, just like we got for first one. So 5 from here and 4 from here. We are already computed, we don't have to compute it every time. Maximum only one time we can compute. So 4 from here and 5 we are already getting. So 5 plus 4, again this would be 9 for us. Okay, so we can make it 9 here. Now come to other guy. What is that? Yeah, so if we come to other guy, this is 3, right? So how many at a distance of 2? this guy also at a distance 1, this is at a distance 2. So these would be in the range up to 2, right? Yes, because this 1 is at a distance of 3, so we cannot include 1. Rest all would be in the range. So how many there are? These are 4 and 4 from here when we connect it, right? When we connect it, we will get directly 4 from here. So 4 plus 4, it would be 8. So we will write the 8 here. So let me write it down, 8. Now we are remaining with the 4th node. So what is the target in itself? So this is our 4th node, and so this is at a range 1, this is at a range 2, this guy also at a range 2, right? At a range 2. Only 1 would not be included. So again this guy also 4 from here, and every time maximum 4 from here when we connect it. So 4 plus 4, this also would become 8. Okay, so we will write it 8. So this would be our answer. So now you would have observed one thing. So for every node we have to count the target within this graph, and then we have one time found, which is creating the maximum value with the k-1 distance. Like in our case, we find either 0 or 4, both of them are producing. So the one which is producing the maximum target of k-1 in the second graph, that we will find only one time, and then we will find the for every node. That is why we created graph. So for every node, target in graph 1 plus whatever maximum we have got in the graph 2. This is what we have to do. Okay, now next thing is how to do that. So you know, the BFS or DFS, any one of them we can use here. So how we will do it? Like we will write a count method, okay, and we will pass k here, which will count. Let's say for example, we will commonly give a method which would be used. Let's say we are calling that method anywhere. One single method would work here. Then we will pass the k value. Then it will give what would be the range of up to that 2. For example, at 0 we called for k equal to 2, so it would accommodate all of them. So we will do it in the DFS way. I'll tell you how to do that. So I will show my corresponding code for it. This will make the sense for us. Okay, so this is my code. Let's read about it, what is happening. So first of all, what we are doing here is we are getting the length of it. So you know that whatever is the length of h plus 1 would be the number of nodes. So this is the number, n is the number of nodes in the graph 1, and m is the number of nodes in the graph 2, right? We already checked that whatever is the length of h plus 1 would be the number of nodes. Now see what we are doing. We have written a build and count method. Okay, so before build and so we will look at build and count, but before that we will look at the count node method. So this count node method is a DFS way of doing it. So this node is the node from where we are starting, and this is one Boolean variable so that we don't repeat the things, because this is a undirected graph, and this is the adjacency list, means list of list. We know that every guy is connected to a list of nodes, so this is just an adjacency list. We call it children, and k is the value that given in the question. So see here, if k is less than 0, then there is no point of finding. It would be a returning directly 0. Otherwise, because we are calling at node, so immediately we are making this guy visited node equal to true, so that next time we don't proceed it to avoid. Now we are making one variable in trace equal to 1. Okay, now see here, we are traversing through the adjacency list of this node, right? This will give us how many nodes it is connected. So list would be here. Now we are traversing through all those guys, just like for 0, this adjacency list would be having 1 and 2 directly connected to, right? So we are traversing through 1 and 2 here. Now we are checking that if they are already true, that means we don't have to proceed, so we are continuing. Otherwise, what we are doing this res. Okay, res equal to res plus whatever is the count minus 1, because whenever we are finding a variable directly connected to, then the remaining check would be decreased by 1, correct? Because see here, if we are looking for k at most k equal to 2 distance, then once we are reaching to the second layer of it, like in this case this, then we have to check the distance of k minus 1, right? Because one distance is already occurred here, so remaining distance would be k minus 1 from here. So that is the reason we are doing in this DFS k minus 1. So what will happen, this DFS is a recursive call. So you can see here, whenever this will go lesser than 0, it will return 0. Right. So its breaking condition would be here. So you can see here, every time we are decreasing -1 so there would be a point when it will lesser than 0, right? At that time we are directly returning 0 here. Okay, so that would be breaking condition. Now you can see that we started res equal to 1. So when the breaking condition would come, we are returning res equal to 1. So every time 1 1 1 1, that would be keep on counting, correct? Because recursion works in a stack kind of thing, right? So in that case it would be like going into the recursion case, right? When 0 would be returned, then top of that it would return 1, then sum of that 1, right? So in that way, finally we would have this res variable, all the count from this node at most distance of k. Okay, so we are doing this. Now this count nodes would be, we have written build and count. Why I'm calling it build and count? Because we are only given edge, right? So from edge we have to create the adjacency list. So for that reason, this n equal to edge length plus 1. So these are the number of node. We are converting this edge to the corresponding adjacency list. So you can see here, this children is the list of list. For every node we will get the list of for which they are directly connected. So see here we are just putting this array list value for every node initially, and then we are adding here. Now see here, we are traversing through edge and we are adding. So from 0 to 1 means first edge connected to second node, first node connected to second node. But because this is a undirected node, then 1 is also connected to 0. So for example, let's say you here 0 is connected to 1 and 1 is also connected to 0. That is why we are calling it 2 times. That 0 is connected to second node and second node is also connected to first node, right? So then we have built our adjacency list. Now what we are doing, this is our result array, which will be keep the count of every node. Okay, so we are using here the count node method. Okay, so this count node method we are calling for this k value, right? So for k value we will get the result, and this result would have the count. Now this utility method will be give us the count of the target, right? Target is, they are calling in the target, whoever at most distance k. So now we will come to this way. Now we are at here. Okay, so see here, n1 and m are the number of nodes in the graph 1 and graph 2. Now see here, this is the count 1 at a distance k from the graph 1, right? That way which we did. So like this, we initially created the graph 1, like here it was 5, then here it was 4, like that, 3. So initially we are counting here. So this count 1 having the count in the graph 1 itself. Now this count 2 we are calculating in the second graph with k minus 1 value. Okay, so now what we are doing here, we are getting the maximum value. So we are finding here maximum value in this count 2. You remember here we found this 0 and 4 at the maximum value. So for same way we are extracting the maximum value here. Okay, so in count, so here in maximum value we are counting from the second array for the second graph. Now what we are doing here, we created this res. Now we are here, what we are doing, whatever count I we have already found for the graph 1, here we found for graph 1 all the count, and this max value we are adding, constant max value for all the answers, just like we did here. Every time we were adding 4 here, because this was the 4 giving us to us. So this was the maximum constant. So we did here 5 plus 4, it become 9. We did here 3 plus 4. We did here this 5 plus 4, this 4 plus 4. So every time we were adding the maximum value we found in the second graph. Okay, then after doing this we are returning this res. This res would be our answer. Now what is the time complexity here? Let me execute this code, though I have already executed it. So what would be the time complexity? So you guys can see here that for the second graph we are every time calling this count function. right? And count is taking, if there, let's say there are m in the, n is the number of nodes in first graph and m is the second graph. So every time we are calling, so this time complexity would be n square plus m square, which is quadratic, right? Or you can say in general O of n square would be the time complexity, and we are taking the extra space as well. Obviously we have to take in the return itself, we have to return an array, so that also would be m plus n. So the time complexity would be order of n square, and space complexity would be order of n. So let me submit. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.